Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the next question. This question is based on the topic of definite integration. It says the value of the integral 0 to infinity 6 dx whole divided upon e to the power 3x plus 6 into e to the power 2x plus 11 into e to the power x plus 6 is. Now students, to find the value of this integral, I will substitute e to the power x equal to t outside the integral. Now when I put e to the power x equal to t outside the integral, then the expression e to the power 3x plus 6 into e to the power 2x plus 11 into e to the power x plus 6 becomes equal to t cube plus 6t square plus 11t plus 6. Now students, when we put t equal to minus 1 in this polynomial, clearly the value of this polynomial becomes equal to 0. So that means by factor theorem, t plus 1 must be the factor of this polynomial. Now when we divide this polynomial by t plus 1, we get the quotient as t square plus 5t plus 6. So this means this particular polynomial can be factorized as t plus 1 into t plus 2 into t plus 3. Now students, I can write 1 upon e to the power 3x plus 6 into e to the power 2x plus 11 into e to the power x plus 6 equal to 1 upon t plus 1 into t plus 2 into t plus 3. And by using the concept of partial fractions, we can further write this as a upon t plus 1 plus b upon t plus 2 plus c upon t plus 3, where a, b, c are three real numbers. Now students, we will find the values of a, b and c, and then we will rewrite the expression inside the integral sign. Now we move further. Now students, we have 1 upon t plus 1 into t plus 2 into t plus 3 equal to a upon t plus 1 plus b upon t plus 2 plus c upon t plus 3. If we multiply both sides of this equation by t plus 1 into t plus 2 into t plus 3, we get 1 equal to a into t plus 2 into t plus 3 plus b into t plus 1 into t plus 3 plus c into t plus 1 into t plus 2. Now students, if I put t equal to minus 1 on both sides of this equation, then I get 1 equal to a into 1 into 2. That means a is equal to 1 upon 2. If I put t equal to minus 2 on both sides of this equation, I get 1 equal to b into minus 1 into 1. That means b is equal to minus 1. And if I put t equal to minus 3 on both sides of this equation, I get 1 equal to c into minus 2 into minus 1. This means C is equal to 1 upon 2. So now we can write 1 upon t plus 1 into t plus 2 into t plus 3 equal to 1 upon 2 into t plus 1 minus 1 upon t plus 2 plus 1 upon 2 into t plus 3. I have just substituted the values of A, B and C in this expression. Now students, we move further. Now students, if I put t equal to e to the power x back into this expression, then we get 1 upon e to the power 3x plus 6 into e to the power 2x plus 11 into e to the power x plus 6 equal to 1 upon 2 into e to the power x plus 1 minus 1 upon e to the power x plus 2 plus 1 upon 2 into e to the power x plus 3. So that means the given integral now becomes equal to, I am taking out 6 common out of the integral. So it becomes 6 into integral 0 to infinity 1 upon 2 into e to the power x plus 1 minus 1 upon e to the power x plus 2 plus 1 upon 2 into e to the power x plus 3 dx. Now students, this particular integral can be broken down into the sum of 3 integrals. The first integral becomes 3 into integral 0 to infinity dx upon e to the power x plus 1. Then we have minus 6 into integral 0 to infinity dx upon e to the power x plus 2. Then we have plus 3 into integral 0 to infinity dx upon e to the power x plus 3. Now students, we move further. Now students, the first integral can further be written as 3 into integral 0 to infinity. Inside the integral, I am dividing up and down by e to the power x. So numerator becomes e to the power minus x dx whole divided upon 1 plus e to the power minus x. Now outside the integral, I am writing 3 as minus 3, and inside the integral, I am writing e to the power minus x as minus e to the power minus x. Now why I have done this? Because if I consider 1 plus e to the power minus x as fx, then the numerator minus e to the power minus x is clearly its derivative, that is f dash x. Now students, this integral has taken the shape of integral f dash x dx divided upon fx, which is nothing but log mod fx plus c. So we can easily find its value. It becomes minus 3 into log mod 1 plus e to the power minus x, and the limits of this integral are from 0 to infinity. Now we move towards the second integral. It is minus 6 into integral 0 to infinity dx upon e to the power x plus 2. Now this can further be written as plus 3 into integral 0 to infinity minus 2 into e to the power minus x dx whole divided upon 1 plus 2 into e to the power minus x. Now again, inside this integral, I have divided up and down by e to the power x. Now students, if I consider the denominator as gx, then the numerator is simply its derivative, that is g dash x. So the value of this integral becomes log mod gx. So we can write this as plus 3 into log mod 1 plus 2 into e to the power minus x. And the limits of this integral are from 0 to infinity. Now students, we move towards the last integral, and it is plus 3 into integral 0 to infinity dx upon e to the power x plus 3. Now this can further be written as minus integral 0 to infinity minus 3 into e to the power minus x dx whole divided upon 1 plus 3 into e to the power minus x. Now students, if I repeat the same process and put 1 plus 3 into e to the power minus x as hx, then the numerator minus 3 into e to the power minus x is its derivative, that is h dash x. So again, it becomes an integral of the form h dash x dx divided upon hx, which is log mod hx. So the value of this integral becomes minus log mod 1 plus 3 into e to the power minus x under the limits 0 to infinity. Now students, we will find their values and finally get the answer of this question. Now it becomes minus 3 into, inside the bracket it is 0 when you put x as infinity, minus log mod 2, which is nothing but log of 2, and then we have plus 3 into 0 minus log 3, then we have minus, inside the bracket it is 0 minus log 4. Now students, it further becomes equal to 3 into ln 2 minus 3 into ln 3 plus ln 4. Now 3 ln 2 can be written as ln 8, and ln 8 plus ln 4, by using the law of logarithm, it becomes ln 32, because log a plus log b is equal to log ab, and minus 3 into ln 3 can be written as ln 27. So again, by using the law of logarithm, that is log a minus log b equal to log of a upon b, this finally becomes equal to ln 32 upon 27. So this is the final answer of this question, and hence option B is the correct one. Now students, in my next video, I will discuss the solution of another question from previous year questions of JEE Main or JEE Advanced. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.